the independent variable is here? The type of treatment. Okay, the IV is the type of treatment. Okay, and is that a between subjects variable or within subjects variable? Okay, some people say within, some people say between. How can you tell? What does it mean if it's a between subjects variable? Different people in each group defined by the variable, right? Comparing separate groups of people. If it's a within subjects variable, what does that mean? Same people being tested at different times. Okay? So we see that a group of alcoholics who are being treated is selected for the study. 1/3 of the participants are given the drug along with their treatment. Another third get a placebo in addition to the treatment. And a third get only the regular treatment. So do we have different groups of people or one group of people being tested multiple times? Different groups. Each one's getting a different kind of treatment. 1/3 of the people are getting the drug and their regular treatment. Another third of the people are getting a placebo and the regular treatment. And another third are getting just the regular treatment. So it's 3 different groups of people. Nobody's getting more than one treatment, right? One version of that IV drug treatment. Okay. So this is a between subjects variable. Is it a manipulated variable or a subject variable? Some people said subject, some people said manipulated. Okay, how can you tell? Okay. Well, the people were selected because they have an illness that's relevant to the type of treatment. That's true. But the question is the variable type of drug treatment a manipulated variable or a subject variable? It's manipulated because you can randomly assign the clients to one of the 3 conditions. It doesn't represent any kind of pre-existing state. You've got a group of alcoholics, and you can randomly assign them to one of the 3 conditions. So this is a between subjects variable, and it is manipulated. Between subjects variable, and it's manipulated. So these are the kinds of questions that I will ask on the problem set, and those are the kinds of questions I ask on the test. You have to be able to apply what we talk about. I won't just ask you to give me a definition. I'll say, here's the situation. Tell me about it. Yeah?
So with this one, how could this be into like a within study?
A within subject study?
Or within subject.
You wouldn't do a within subjects design with this particular type of IV because you're talking about treatment. And in order to do we're going to talk about within subject designs a little bit more today. But once a person had experienced one of the treatments, they become so different that you can't put them into another treatment. Because supposedly if it works, then they're not sick anymore. So when you talk about drug treatment, typically you are talking about between subjects designs, because if the treatment works, you can't go back. And you don't want to make them sick again so you can treat them again. And if they're better, they don't need any treatment anyway. So you couldn't do this one as within subjects. All right. Any other questions? Okay. Don't worry if you didn't get the answers right. The reason that we ask is so that you know whether or not you might want to go back and look at that stuff again, or if you have questions, you can talk to me or talk to one of the TAs. But this is the kind of question that you'll see on the problem set, one of many kinds of questions. So you'll want to download the problem set. My problem sets in this class, along with lots of other documents, are kind of fill-in-the-blank things. So they look like this. And what you do is you type your answer into this box. It will expand to accommodate your answer. And then you will submit your completed document online before you come to class, and then you'll bring a copy of it with you for when we talk about it in class. And you get credit for doing it if it's uploaded, not if you have your hard copy in class. Okay. So please make sure that you try to answer every question. Problem sets aren't scored about whether you got it right or wrong. They're scored by whether or not you tried to answer the questions. And you'll find out in class if you were wrong or not. Problem sets, I've in the past had students who say, well, problem sets are only worth 5 points. It's a check-in. I don't care, so I don't really need that. And they get to the end of the semester and they're like, where can I get another 25 points? And I said, well, if you've done 5 problem sets, you would have 25 points. So 5 points doesn't sound like very much, but the idea is so that it doesn't hurt you if you miss one. But if you do it ahead of time and then come to class and we talk about it and I say, okay, which ones were hard, you can actually answer that question and we don't spend time talking about things everybody knew how to do. Okay? All right. So, let's talk about experiments again. Okay, so last time we stopped while we were talking about between subjects designs and about different ways that you can try and address the challenge of between subjects designs, which is creating groups that are similar enough to compare in a meaningful way. Now, does anybody have any questions about any of these things or about the handout from last time where we talked about block randomization and matching? Anybody have any questions about that before we move on? If you do, it's okay. I know, the sweater is distracting. Okay, I'll go back to the black line. All right. So, let's talk about within subjects designs now. Now, as we said at the beginning of class, within subjects designs are designs where you are comparing a group of subjects to themselves somehow. You're comparing them, you're gathering data from them in the different conditions defined by the independent variable. So if you have an independent variable with 3 levels, that means that you're going to test each subject 3 times. Once in condition 1, once in condition 2, and once in condition 3, something like that. Now, we describe between subjects designs in terms of whether you did random assignment alone to create the groups, whether you did matching first before you did random assignment, or whether you had a subject variable and the groups were naturally existing groups. When we talk about within subjects designs, we talk about whether the subjects had a complete or incomplete within subjects experience. A complete within subjects variable is one where the subjects experience each condition more than one time. So it's not just they get one exposure to whatever that treatment is, but they get multiple exposures to the treatment, multiple opportunities to give you data about their response to that treatment. In an incomplete within subjects design, they get only one exposure. And sometimes that's what you have to do. You can only expose them one time to the condition because once they've experienced it, they're somehow different and you can't go back and expose them to it again. So we always think about whether something is complete or incomplete when it comes to within subjects design. We also care about how many random orders of the conditions we use. So, for example, if I have an IB with 3 levels, and it's within subjects, I can still think of those levels as A, B, and C. And then I can still use block randomization to tell me how many possible orders I could use, right? ABC, BAC, CBA, right, just like before. Okay. But each one of those now represents a possible order that I can expose the subjects to the conditions in. So, for example, let's talk about dogs again. Imagine that we wanted to take our dog food study and turn it into a within subjects design. We could totally do that. I could take, for example, let's switch over here, put on the document. Whoa, big. All right, so I can take my 3 dog food brands, and I can say, all right, I'm going to give all the dogs in my study the chance to eat each of these foods. I want to know how one group of dogs, I'm going to compare. This group of dogs, do they eat more chunks and lumps? Do they eat more Purina dog chow? Or do they eat more Kroger kibble? And every dog's going to get a chance to eat every kind of food. Now, if I do this as a complete design, I'm going to give each dog multiple opportunities to eat each food. Okay? Because remember, complete designs are for multiple exposures to each level of the IV. But I need to switch it up. Okay? I need to mix up the order in which the dogs receive the food. Why might I need to do that? Why would I have to mix it up so all the dogs they don't all eat chunks and lumps first, and then they all eat Purina dog chow, and then they all eat Kroger kibble? Why would I want to mix it up? Yes?
If they eat one first, it might affect how they taste the others or how they react to the other one.
Right. So if we're exposing each dog to all of the different foods, then we want to mix up the order because we don't know how eating one food might influence the way they respond to another food. Okay? And this is what's referred to as a sequence effect. The biggest challenge of a within subjects design is not creating groups that are similar enough to compare. It's not a problem. We're comparing all the same subjects to themselves. We don't have to worry about things like individual differences and stuff like that, because all the same subjects are experiencing every condition. What we have to worry about are sequence effects. We have to worry about how the order in which the subjects experience the conditions might alter their response. Now, your book calls these order effects. That's another perfectly good word for them. But there are actually a number of different kinds of sequence effects. And we tend to categorize them into 2 groups. We can talk about carryover effects and progressive effects. A carryover effect is one where the 2 conditions, so you say you expose the subject to 2 conditions back to back. And maybe their experience with the first condition influences how they respond to the second condition. But the effect disappears pretty quickly. So for example, if we think about dog food, say that I have dogs come in and they eat their first food. And they're all, I don't know, if your dogs are like my dogs. My dogs, when you give them a new food, they're really excited about it because it's new. And they love to eat new food. So they will eat way more new food than they would normally eat of their regular food, because the regular food's boring. They'd be eating it all the time. They don't care. So say the dogs come in on the first day, they eat a ton of food because it's new, it smells different, and it's good, okay. And then the next day they come in and they're just like, God, I'm still full from eating 50 tons of food yesterday. And so they don't eat as much. Well, by the third day when they come in to eat some food, they probably digested all that food, so now the effect has disappeared, right? So on the third day they might eat more again. This is a carryover effect. There's a lingering influence of one experience, one stimulus, on the subject's response to a subsequent stimulus. But that effect disappears pretty quickly. That's different than a progressive effect. A progressive effect is one that may occur over the course of stimulus presentation. So, for example, say I'm asking people to respond to a stimulus on a computer screen, and they have to kind of focus their eyes in the middle of the screen, and then I tell them, okay, lights are going to show up around the edge of the screen, and if it's a red light, hit a button with your right hand, and if it's a green light, hit the button with your left hand, right? So some complicated set of instructions. And in the beginning, they're not very good at it because it's a hard thing that I'm asking them to do. And they have to get used to hitting the different buttons and getting the right response and stuff like that. So in the beginning, they're not very good at doing the task I want them to do. But in the end, they get much better because they've practiced it. So this is a progressive effect. It means that the stimuli at the beginning of the study will all have junky data because people are slower and they're less accurate because they're trying to learn how to do what it is I'm asking them to do. But by the end, they're really good. So their performance, the quality of their performance is going up over the course of the study, which is why we call it a progressive effect. And they get better and better and better as they learn what it is you want them to do. Alternately, you can have kind of a reverse phenomenon. If you're asking somebody to do something that's challenging, in the beginning they might have more energy, and the longer they have to do this challenging task, the more and more tired they may get. And so their performance may drop off because they get fatigued. Okay, so the data at the beginning of the study will have their best attention, their most focus, but by the end they're tired and they don't want to do it anymore, and so the data at the end are kind of junky. Because of these kinds of sequence effects, because we know that these things are likely to occur, we have to switch up the order in which we present the conditions to the subjects so that not everybody gets the same conditions at the beginning and gets the same conditions at the end. Because we want to make sure that any effects that might emerge, any sequence effects that might be present, can get canceled out. So some people might experience the first condition first, and some people might experience the second condition first, and some people might experience the third condition first. And that way, if whatever happens first influences what happens next, well, you're mixing it up, right? So you get some good data and some bad data in every condition, and it kind of washes out. It doesn't really matter. And doing this, mixing up the order in which the subjects experience the conditions, is called counterbalancing. And we counterbalance in two ways. We can either do a full counterbalance, which means we use all the possible random orders. So we mix it up as much as possible. All the possible random orders of the conditions are used. Or we can do partial counterbalancing, where we select a systematic subset of the possible random orders. And which one you do depends on how many stimuli you have, and how much data you need to collect, and how many subjects you have, and things like that. So if we go back to this handout now, okay. So we're going to, right now we've got a complete design, right, where we're going to present our dogs with these different foods. Well, one thing I can do is I can use block randomization, and I can take 3 dogs over some number of days, and I can feed them the foods in different orders using blocks. For example, on the first day, I can say, okay, so I got 3 dogs coming in, I'm going to randomly assign Rover to get chunks and lumps first. Fido's going to get Purina first. Pumpkin's going to get Kroger first. You see that's a block? It's a block because we have 3 foods and each one of the dogs is getting one of the foods. So every day we're going to gather data about each food, but we're going to get that data from a different dog. Next day. Now, Rover had chunks on the first day, so now I have to give Rover either Purina or Kroger. And I choose Purina, right? That being the case, that limits what I can do in these other conditions, right? Because every day I'm going to gather data from every condition. I'm going to get a full block worth of data. No 2 dogs are going to eat the same food on any given day. And I'm just going to keep rotating like that. Chunks, Purina, Kroger, Purina, Chunks, Kroger, Purina, whatever. Just mix it up. Okay? Over and over and over again until I've got as much data as I need. And then what I'll do is I'll average all the measures of how much Chunks and Lumps they ate, all the measures of how much Kroger Kibble they ate, all the measures of how much Purina 1 they ate, and I'll compare the amounts for my group of dogs. Does that make sense? Yes?
Would it be possible that the fact that Pumpkin is eating Purina 2 times in a row, like that you said, you know?
No, because these are random orders. So random orders don't always look random, but that doesn't make it any less random. So chances are that will have zero influence at all on the outcome of the study. I mean, it's an order. It could happen. All right, so we can do simple block randomization where we just keep going through. And you'll notice also that we have 3 foods. And when I assign the dogs their food to eat for a given day, I make sure that I'm cycling through a block for each dog also. So this is a block, this is a block, this is a block. And I will try and do complete blocks for each dog also. So I wouldn't stop after day 7, for example, because I have 3 different foods to eat. So I want to keep offering the food in some multiple of 3 so that I can always have the same amount of data for every food from every dog. Now, if you don't have the time or you're not able to do this kind of lengthy rotation where you're going over and over and over and over, you just keep doing more and more blocks, you can simplify it a little bit. This still counts as a complete design because the subjects are experiencing the stimuli more than once, each condition more than once. This is something called ABBA counterbalancing. Take a look at that. Tell me if you can tell me why it's called ABBA counterbalancing. What am I doing in my presentation of stimuli? Yes? Hmm?
You reverse it.
Say it louder.
You reverse it, like you start how you end.
Okay, so you reverse it. What's it?
That's the order.
The order. Okay, so I pick a block for each dog. Rover's block is Chunks, Purina, Kroger. Okay? And then I pick a block for Fido, Purina, Kroger, Chunks. And then I pick a block for Pumpkin, Kroger, Chunks, Purina. Okay, so I picked 3 of the random orders, and I gave each one a different random order for the first 3 days. And then to get the second random order, so I have a complete design, I just flip it, right? So AB, that was the order I did it first. BA, I just turn the order around. I mirror the order back. So I have one pattern going in and the mirror pattern going out. And this is useful if you expect to have some kind of progressive effect in particular, because, so say whatever food is offered on the first day is, maybe the dogs are like, it's the first day and they're in a new place and they don't know me and they don't know my lab and it's strange, they're not used to having to go somewhere to eat, usually they just walk into the kitchen. So on the first day they're really nervous and they don't eat very much. And then the next day they come back, and the next day they come back, and as they keep coming back to the lab, they get more comfortable and more used to the situation, so they're able to eat more. So whatever food I offer them on the first day, I'm going to have really low returns for. They're not going to eat very much at all. But by the end, they'll be the most comfortable, so they should eat the most. So the idea with ABBA counterbalancing is, if you think you're going to have some kind of linear effect, some kind of progressive effect, this kind of counterbalancing should allow you to kind of cancel out the difference and not have to worry about the sequence. And you can see we call this ABBA. Even though there are 3 conditions here, we don't change it to ABC, CBA, or anything like that. It's just ABBA counterbalancing means whatever order of the conditions you use first, use the reverse order of the conditions second, and then you're done.
So to counterbalance it, do we add them together?
So in the end, what you will do is you will take all the scores for chunks and add them and average them. And you'll take all the scores for Kroger and you'll add them and average them. And you'll take all the scores for Purina and you'll add them and average them. And then you compare across those. Yeah. So when you do that, if they ate a little bit here and the most up here, it should cancel out and you'll get a typical amount that they would eat. And you'll notice in this case, with this particular strategy, all the dogs get some food back to back, right? It's whatever happens to be at the end of the first sequence, because that's exactly what they're going to get at the beginning of the second sequence. So these are both ways, just simple block randomization where you just keep doing block after block after block after block after block until you have as much data as you need. Or you can do ABBA counterbalancing. And they both count as complete because in both cases, the dogs are experiencing each food more than one time. Now, we can switch it up and do this as an incomplete design if we want to. Purina subject, I like that. So, you've got, we do this as an incomplete design. Each dog is only experiencing each food one time. As an incomplete within subject's design involves each condition being experienced once and only once. So each dog's going to get all three types of food. That's what makes it a within subject's design. Each dog is going to get each food only one time. That's what makes it an incomplete design. And we're going to deal with sequence effects by counterbalancing, switching up the order. Now, if I do full counterbalancing, that means I use every possible random order. So at minimum, I would need 6 dogs now, because there are 6 possible orders of 3 things, right? A, B, C, B, C, A, C, A, B, right? There's 6 possible orders. So if I'm going to do full counterbalancing and get information on every possible random order of these 3 foods, I have to have at least 6 dogs. And I could expand that. If I've got 6 dogs, that's fine. That's the minimum number I would need. I could continue to have multiples of 6. So I could have 12 dogs or 18 dogs or whatever. But each dog would experience each food only one time. And each dog experiences a different order. But I'm getting data on all the possible orders. And then we would average things across again. So add up all the Purina and average. Add up all the chunks and average. Add up all the Kroger kibble and average. Okay, same thing. Now, what happens though if you don't have 6 dogs or multiples of 6? What do you do? Well, you could go with not full counterbalancing. You could go with partial counterbalancing. And that's where you pick a very specific subset of the orders and use that subset. And here's an example of what we could do if we did that. Now take a look at this. This is like the simplest version of this experiment. Can you tell me what's the system? This is a systematic subset of the possible random orders. What's the system? Can you tell?
System like ABC.
Okay, ABC. Yeah. What's the next one?
BCA.
Okay. And what's the next one? Okay. And what do you notice about that selection? This is what's referred to as a Latin square. What that means is, here's the secret to a Latin square. Every condition in every position. Okay? That's my little rhyme for remembering about a Latin square. Every condition in every position. Okay? So, what does that mean? Well, every condition. We have 3 conditions, right? A, B, and C. And what are the positions they can take? First, second, or third. So we need a Latin square. If we're going to systematically select some subset, and we want to get maximum counterbalancing with a minimum amount of effort, then we want to have every condition in every position one time. So notice, A in the first position, A in the second position, A in the third position. B in the first position, B in the second position, B in the third position. And C, obviously. Either in the first position, second position, or third position. So if we're going to have an incomplete design with partial counterbalancing, an easy way to make sure that we get as much counterbalancing as possible, even though we're limited in the number of exposures we can give, is to use a Latin square. Latin squares are easy to do. All you have to do is start with some possible random order. You can pick any one you want. We could start with B, C, A if we wanted to. Any of the random orders is fine. It makes absolutely no difference which one you start with. And then you go through, we call this a random order with rotation. So basically you say, okay, I said B, C, A here. Now what I'm going to do is take whatever's at the beginning, bump it to the end, and scoot everything over. So now it becomes C, A, B. And what would the last row be? Yeah. Make sense? So you can do it, and what if you were going to do it with 4 things? Let's say we go D, A, C, B. Okay, what's the next row? A, C, B, D. Okay, what's the next row? C, B, D, A. What's the next row? B, D, A, C. B, D, A, C. What's the next row? There isn't one. It's a square. That means you have the same number of rows as columns. Latin square, not Latin rectangle. So stop after, because you've got, with 4, we've got every condition in every position, so stop. If you do another one, you'll have extra. You don't want extra. You want everything to be even. Even, even, even. You want the same number of data points in every condition. So that's how we can that's how we can use blocks to randomize. So if I have an independent variable that's within subjects, and I can do this kind of, or any of these kinds of counterbalancing strategies, that it's possible for me to randomize the order in which the subjects experience the conditions, then we say that's a manipulated variable. Because we're randomizing the order of presentation. If I cannot randomize the order, if it's fixed, say for example, I have an independent variable that's time. I can't randomize time. Right? Pre-test, post-test, for example. I can't randomize time. So if you have a within subjects variable and it's time, then it's not manipulated, it's a subject variable. People are chosen first because they haven't experienced, they have the inherent property of not having experienced something, and then at the end they're selected because they've had the experience of whatever it is you expose them to. So if the independent variable is time, that's a within subject variable and it's a subject variable. Because it reflects, it's not manipulated because you can't randomize it. Now, biggest challenge for between subjects design is creating groups that are similar enough to compare. Biggest challenge for between subjects design is creating groups that are similar enough to compare. For within subjects design, it's dealing with sequence effects. But whether you're doing between subjects or within subjects, your next biggest concern is managing the internal validity of your study. You're always worried about threats to the internal validity. You want to avoid confounds as much as possible, avoid third variables that could get in the way of your data interpretation. And it doesn't matter whether it's between or within. We care about internal validity. Because remember, we can't make a causal claim if our internal validity is too weak. And that's what experiments are for, making causal claims. So we need to maintain our internal validity. Now, you have a very detailed handout that is related to a table in your book that these are all different threats to internal validity. Different things that can threaten the internal validity of a study. Things that we have to keep in mind. I've given you examples for each one. The main ones that we worry about are up here on the board. These are big ones. The first is history, an effective history. If your study is taking place over an extended period of time, you have to worry that the historical situation may change over the course of your study. So that the data you gather at the beginning isn't the same as the data you're gathering at the end. So, for example, imagine that in August of 2001, you decided to do a study on people's views of airline safety. So you're gathering data, asking people about their views on airline safety. And then, what happens? September rolls around, September 11th rolls around, and all of a sudden, people's views on airline safety are fundamentally changed forever. Right? You can't now ask questions. You can ask people questions, and certainly it will be interesting to see how their views have changed, but history has changed the playing field. You can no longer just think of, I'm asking questions about airline safety. Now it's, I'm asking questions about airline safety before the historical event, and I'm asking questions about airline safety after the historical event. You just can't change that history. So, and it doesn't have to be something that major. It could be something less dramatic. It can be anything that causes the people who give you data early in the study to respond differently than the people who give you data later in the study. And it's some external event that you have no control over. So it's not, you can't, it's not a third variable you can control for. It just is. And if it changes the playing field too much, then you might have to just start over, because the internal validity of your study is so jeopardized at this point that people can say, well, the reason you're getting different answers is because of that big event. Another thing that we have to be concerned about is maturation. This is particularly a concern when you're testing people over a long period of time, and you're testing the same people. You think about it, I mean, say I'm looking at motor skills. Well, I mean, kids are just going to develop motor skills naturally over time. They are going to get better at doing certain things, just naturally. And that change doesn't necessarily have anything to do with the activities I'm doing with them or anything like that. So if I take a long time to gather data, and my dependent variable could be influenced by naturally changing ability, then I have to worry that maturation may represent a threat. And I might need to make sure I conduct my study very quickly to avoid maturation being a threat. But you can imagine with the within subjects design, if you're gathering data over a long period of time, that especially if you're working with children or you're working with individuals who are naturally expected to change their physical ability, either go up or go down, then that could represent a threat and jeopardize the quality of your data. Instrumentation. When you're gathering data, it's not uncommon to use instruments. like computers that record response time, or cameras that videotape what the subjects are doing. And equipment breaks down. Equipment wears out. And even the best calibrated device will lose some of its calibration as you use it. That's just how it works. And depending on how much the equipment changes in how it measures, you might get better data at the beginning than you do at the end because your equipment isn't measuring things in the same way. So you have to be concerned that the tools that you're using are always in good condition and they're always measuring things the same way over time. And that may involve, buying multiple versions of something and then just replacing it with a brand new version every so often because you have to make sure that you're continuing to get good data. Another possible threat is testing. When you expose subjects to conditions in a study, especially within subjects, they may learn from the experience. And as a result, they may be better at subsequent conditions than they were in the beginning. So we get a testing of that. So you might say, oh, look, there's so much, because the subjects are improving over time at performing whatever task, for whatever reason, you can get a threat of testing. So the data at the beginning of the study is fundamentally different than the data at the end because the subjects have changed in their knowledge of what they need to do. Regression to the mean has to do with the fact that the subjects that are chosen for a study are sometimes chosen because they represent an extreme group. So for example, if I want to study ways to teach children how to read, then I might select kids who are struggling with reading because these are the kids that need help. Maybe they're really struggling with reading. So I select them for my study and then use different ways to try and teach them how to read. But the thing about picking subjects that are in some extreme state, extremely depressed, extremely aggressive, extremely struggling with learning how to read, whatever, is that we don't stay extreme long term. If you're in an extreme state, you will naturally return to a more typical state over time, whether anybody does anything or not. Has anybody in here ever been in love? Nope. Nope. Fallen in love. Remember that? The first time you fall in love and it's so freaking great. Remember that? You're just excited all the time and you're all super happy and it's rainbows and unicorns and sparkling and it's so fabulous, oh my gosh, right? And you're in a pretty extreme state where, you can't think unless it's about that person. And you can't do anything unless it's that person. And you're all about that person. And what happens? In that state, you make crazy decisions like getting married. And then you don't stay in that extreme state anymore. And all of a sudden, you wake up one morning and go, wait a second. Because you know how when you're in that extreme state of being in love, all the little things they do are just cute. And then, when you're not in that extreme state anymore, they're annoying. Right? You're like, oh, it's so cute the way he leaves his towel on the bathroom. No, it's not cute. Whatever. Toilet seat up, you're like, oh, I don't really care, until you fall in. Right? 3 o'clock in the morning, and all of a sudden it's not cute anymore. Right? So you don't stay in those extreme states. You revert back to a more normal thinking state at some point. And it's true with depression. If you've ever been severely depressed, you know that even if you don't get any treatment, you don't take any medication, you will not stay depressed in that extreme way. You just don't stay like that. So this is what regression to the mean is about. It's that when you pick subjects that are in some extreme state, whether you do anything or not, they will move away from that extreme state over time. And if that's the case, you can't attribute that change to your treatment because it would have happened anyway. And then there's attrition. Attrition has to do with subjects dropping out. And that's a big deal because if you try really hard at the beginning of your study to create groups that are similar enough to compare, you're trying and trying and trying to create groups that are similar enough to compare, and then people leave. Well, say you made these 3 groups. You're looking at, exercise, and you have one group that's doing really hardcore weight exercise, and one group that's doing aerobic exercise, and one group that's doing kind of a combination of the 2 things. And you worked really hard to get these 3 groups and distribute the different levels of fitness across the groups and all that other kind of stuff. And all the people who are doing the really hard weight training, or like 3 people in that group are like, this is bogus, I don't want to do this anymore, and they quit. Well, so now your 3 beautifully similar groups are no longer similar anymore. Or if you're doing a within subjects design and you're having people do different kinds of exercise, and after they've done it for a little while, some people just quit. Well, now you don't have the same amount of data in each condition because somebody just left. And this can happen, sometimes they don't quit, sometimes they die. Right? People, if you're studying elderly people, sometimes people die during your study. And your lovely similar groups are now no longer similar because you've actually lost participants. So any of these things can negatively influence the internal validity of your study because they offer alternate explanations for the change in your subject's behavior. It doesn't have anything to do with whatever it is you're doing to them, whatever conditions you're exposing them to. External events, natural physical change, problems with your equipment, changes in the subject's level of experience with the task, natural return to non-extreme states, and people just quitting. These will all threaten the internal validity of your study. Now you'll notice if you take a look at the worksheet, or not the worksheet, the handout, for each one of these examples, let me see if I can maybe go. There are more examples on this worksheet, on this handout. I don't want to call it a worksheet. More examples on this handout. These are connected to the ones that are addressed in your book. I've given you an example for all the ones that are addressed in your book. And there are also some that represent combinations. So for example, you can get an effect, a selection effect. A selection effect is one that affects one of your groups differently than the others. Okay, so one of your groups has some different experience than the other groups, and that can cause a problem. And selection effects can interact with other kinds of threats to internal validity. So you can get a history by selection effect, which means that one of your groups, say you're comparing 2 groups, one of the groups experiences a historical event and the other one doesn't. So imagine, for example, you're studying people's exercise choices and how much they exercise regularly, and the exercise program that you're looking at involves people going outside and going for a walk, going for a jog, going wherever. And one of the places where you're doing the study has really bad weather for a period of time and nobody wants to go out and do it, while the other place has nice weather and everybody keeps generating data for your study. Well, that's a problem. That's a history by selection effect. The bad weather only affected one of your groups, not both of your groups. So that's a concern. Maturation by selection can happen because some groups mature at different rates than others. So if you're studying, for example, if you're looking at studying behavior, freshmen studying behavior changes more than seniors studying behavior. Does that make sense? Over a 12-month period, if you were going to look at how people's studying behavior change, because in the beginning, when you start college, remember how it's not like high school? And you kind of think, you're like, oh, high school, I never had to read a book, I never had to do a thing. And then you get to college and you're like, oh, dang. That's different. And so over the first year, there are more things going on. And it's not just that you're learning how to be a college student, but you're also, for some students, it's their first time living away from home. There's all this other social stuff going on. They haven't figured out the balance yet. So they're maturing at a different rate than seniors who have got it figured out, right? They've kind of figured out the balance for the most part. They know what they have to do. They've got the job thing worked out, the relationship thing kind of figured out, or at least they have a sense of what they need to do to get the job done. So that would be a selection by maturation effect, where one group is simply maturing at a different rate than the other group. You can also have an instrumentation by selection effect, where, for example, if you're gathering data across multiple labs, and this happens where we'll gather data around the country at different situations, different settings, with different groups of subjects, and you have to try and make sure that everybody's using the exact same kind of equipment, so the measurements are all the same. And what happens if the equipment in one of the labs breaks down? Well, now you don't have data from that particular lab anymore, and you've got an instrumentation by selection effect, because it only affected one of the groups where you were gathering data, not all of them. So please review this handout. I mean, I'm not going to go over it in any extra detail because it is covered in your textbook, and there are examples here that I think are pretty clear. So please review that, and if you have any questions about the different types of threats to internal validity, please let me know. Now, as I mentioned before, problem set number 1 is posted online, and it's due in a week. And you will want to refer to all the different handouts and stuff that I've given in class as you work on that problem set. The first problem set is pretty long, and that's so that you can get practice with application. So I would encourage you not to put off doing it until the last minute, because you probably won't get it done that way. We are going to move into talking about statistics in our next unit. Okay? Not for the first exam, but for the second exam. And what I want you to keep in mind is that I want you to keep in mind the connection between the methods that we're talking about and the statistics that we're going to talk about. So the kind of statistic we do in this class on experimental data depends on how many levels there are in the IB and the kind of comparison that we're doing. So if we're comparing two groups, and that's what we're going to do first, we're going to talk about comparing just two groups, then what we're going to do is t-tests. And we are going to learn between subjects t-tests and within subjects t-tests. It's two different tests, and that's what we're going to focus on in unit number 2, is doing all the calculations necessary for independent groups and related groups t-tests. When we move up to having 3 or more levels, then we change the test we're doing completely, and we do analysis of variance. So we will do analysis of variance, or ANOVA, for a single independent variable in Unit 3. That's what we'll study for Exam 3. And then in Unit number 4, we'll talk about what happens when you have more than one independent variable. And so you have a minimum of 4 different conditions with 2 independent variables. And that's another kind of analysis of variance. And that will be what we do in Unit 4. And we will always focus on doing between subjects design and within subjects design analysis. Okay, so we'll learn how to do both. Except when we get up to the multi-IV studies, then we only talk about between subjects because it's easier, and at that point we're getting closer to the end of the semester and we have to start writing papers. So we just talk about the easier one because you'll have the general idea at that point and you'll be able to figure it out. The analysis does not change depending on whether the IV is manipulated or subject variable. So that doesn't influence which statistic we do. All that matters is how many levels does the IV have, and is it between or within subjects? That's what dictates which analysis we do. What changes as a result of whether our IV is manipulated or subject is how strong of a claim we can make. If it's truly a manipulated variable, and we really are able to do the randomizing things we need to do, then we can make a causal claim based on our findings. But if it's a subject variable, that means I'm not able to do the randomizing things, either to randomly assign subjects to groups or to randomize the order in which subjects experience the IV levels. And in that case, the best I can do is an association claim. Maybe a strong association claim, maybe a weak association claim, depends on my data. But I cannot make a causal claim with a subject variable IV. Can't do it, because it's a quasi-experimental study. All right. Does anybody have any questions about that stuff? Think you got it? Okay. You have, let's see, what exciting stuff do we have going on next? Quizzes, yeah, you got some quizzes and stuff coming up, right? All right, and you guys do not have labs yet. You guys have lab on Wednesday, is that right?
Yeah.
All right, and you guys did you guys do the Psych Info quiz already? Is that the one that's coming up?
It's the APA.
All right, and the APA. Okay, and you guys remember, 2 note cards, right? One for Psych Info, one for APA. Handwritten notes on one side. They have to be 2 different cards because you turn them in after each quiz. Okay? For the Psych Info quiz, obviously you'll be able to use the internet because you have to log in to search an online database. But for the APA quiz, you don't get to use the internet. So make sure you take good notes off that tutorial. Okay? I'll let you go study because I know some of you are going, oh yeah! Yeah, we do have those 2 quizzes coming up next time. Maybe I should totally do that tutorial that I was supposed to do over the weekend. All right, get out of here. Have a good day.